Hi everyone, this video is going to be on formulas. It's the first of a two-part video. In this first one we will do mostly looking at formulas and do a couple small examples. In the second video we will talk about solving for a variable in a formula. So for this first formula we're going to talk about the simple interest formula, and you may have seen it before. The simple interest formula tells us that interest is equal to the principal times the rate times the time. So when we talk about this, when I say the interest, I'm talking about the interest either earned on money you've invested or interest owed on money you borrowed. Simple interest is important here. Make sure you realize it's a simple interest formula because there are other interest formulas. And for short we call this I equals PRT, principal, rate, and time. Is what the PR and T stand for. Let's make sure we know what those are. So principal, that's the initial amount either invested or borrowed. Right? The rate is our interest rate, and they usually tell you that in the problem, but it's the interest rate as a decimal. So if they tell you an interest rate of 5%, for example, to convert that to a decimal, right? If I had 5% as the rate, to convert it to a decimal, you take the decimal point, you move it 2 to the left, so it would be 0.05. So as a decimal, we would use 0.05. That's if the example told you it was 5%. Keeping in mind that if you're not sure about moving the decimal place, you could always divide out of 100 for a percent and get that same decimal on your calculator. So the rate is the interest rate as decimal, and time is going to be the time in years of the investment or for the loan. So let's look at an example using this formula. So it says Doug invests $7,000 at a simple interest rate of 3%. If he earns $840 in interest, how long did he invest for? So first thing you should be looking for is thinking about, okay, what am I trying to find here? In this case, how long means that we're looking for time. So you might want to say let t equal time. You don't necessarily have to write it in a problem like this because it's kind of straightforward. But let t equal time, we use these let statements when we get into other chapters. So it's important to understand that a let statement is a way of defining your variable. The other thing you should notice right away is that they say simple interest rate. So if I say simple interest in a problem, that immediately is telling you you're using I equals PRT, right? Interest equals principal times rate times time. And now let's talk about the pieces of this formula that we know and what we're trying to find. So it says he invests $7,000. When I say invests, that's the initial amount he put into it. So remember, the initial amount we call P is the principal. So the $7,000 is going to be our principal. So if I was filling in down here, I'll fill in 7,000 for P. At a simple interest rate of 3%, if the interest rate is 3%, this is going to be R, and R is going to equal 3%. As a decimal is 0.03, so R is going to be 0.03, so it'll be 7,000 times 0.03. You should put parentheses here to multiply. And then T is time, and we're trying to find time, so I'll leave that as T here in the problem. And what's I? Well, I is how much he earned in interest, $840. So that's I, so we have 840. And so now, if you filled in for 3 of the 4 variables, you can always solve for that 4th variable. The first thing I would do is probably multiply the 7,000 to the 0.03. So I have 840 equals, and then we'll do 7,000 times 0.03, and that gives me 210. So this will be 210. T, and then if we want to solve this for t, remember this means 210 times t, so to get t alone on one side we'll divide by the coefficient, so we divide by 210. So end up with t equals 840 divided by 210, and that comes out to 4. Make sure you know the units, those are important. What we're trying to find, time was in years we said, so 4 years was the investment that you made, or for the length of time of the investment that you made. So keeping that in mind, other problems you might see like this may give you, 3 of the 4 parts, but they may not give you time, right? They could give you everything but the rate, everything but the principal, or everything but the interest, and you'll have to find that by substituting into the formula. Let's take a look at another formula. So another formula that we use fairly often is the distance formula. And the distance formula you've probably seen before. It's distance equals the rate times the time. And for short, you might see this as D equals RT. Keeping in mind that when I say this, you probably use this when you're like traveling in a car at a certain speed and you're trying to figure out how long it'll take you to get somewhere if you maintain that speed. You've probably used the distance formula before in your regular life. The rate is usually in something like miles per hour, feet per second. The word per in there typically tells you about a rate. We're talking about a distance problem. So for this example, it says a car travels at 65 miles per hour for 3.4 hours. How far did the car travel? So first off, how far is the question? That means we're looking for the distance. So we know we're talking about the distance equals rate times time formula. And we're trying to find the distance, so I'm going to keep that as D. It's equal to the rate times the time. Well, what's the rate? The rate is 65 miles per hour. That word per in there is indicating that that's the R. So that's 65 times the time. Well, how long? 3.4 hours, so that's your T. So 65 times 3.4. So to evaluate this, right, we just do D equals 65 times 3.4, and I'll do that on the calculator. 65 times 3.4, that comes out to 221. What are the units? Well, the units for distance, in this case, are in miles, because you can see it in your rate. So these distance units are in miles in this case. If you're not sure, one way you can find the units, remember distance is equal to rate times time. So if I was just multiplying the units, all right, not really worried about the numbers, the rate was in miles per hour. So if I wrote this as miles per hour, that's how I'd write it. The word per there means the hours are really in the denominator. Times the time, which we know was in hours. And then when you multiply this, miles per hour times hours, hours would cancel and you're just left with miles. They call this dimensional analysis. You may have seen this type of thing if you're working in science before. But, it's important to understand the units. It comes from really the multiplication, but you don't necessarily have to show this if you understand what the units are going to be. The next set of formulas we talk about are geometry formulas. And, some of the ones that we talk about in terms of words are perimeter and area. The perimeter is the distance around the outside of an object, or a geometric figure if you want to call it that. All right, so I'm talking about, essentially adding up the sides, right? That's what perimeter really tells you about, is adding up the lengths of the sides. The area is the space within the boundaries of an object. So if you were in a rectangular room, you would say the perimeter would be, the length of all the walls, from side to side being added up. The area of the floor would be that space that's taken up within the boundaries of those walls. Something important to remember about area. Area always has units that are squared. So units of area are always squared. So you might hear things like square feet or feet squared, making sure you understand that units of area are always going to be squared. Let's take a look at some specific geometric figures here. So the first one we have is a rectangle. We'll draw it just so we can see the different dimensions. A rectangle typically has a length and a width. I'll call the variable L the length and W the width. And to find the perimeter, right, now from here forward I'm going to use P for perimeter and A for area. The perimeter is going to be equal to, what's perimeter? It's the distance around the outside. So you add up all the sides. So if I'm adding this up, right? I've got length, width, so length plus width. What's this side going to be? Well, this is also going to be L. And then what's this side going to be? Well, this is also going to be W because the opposite sides are the same in a rectangle. So the perimeter is going to be equal to L plus W plus another L plus another W. And then simplifying this formula for perimeter, right? If I have like terms, L and L are like terms, L plus L is 2L plus W is 2W. Make sure you have that plus in between. A lot of people leave that off. You need it there. Otherwise, it means multiply, and the plus means add. So 2L plus 2W is our perimeter formula. If you ever get stuck, you could just say add up all four sides. But you should know the formula for the perimeter of a rectangle. For the area of a rectangle, the area is equal to the length times the width. All right, and remember the units will be squared. Now, kind of an example of the units here, right? Length is in feet and width is in feet, so feet times feet would be feet squared. You know, if it was centimeters times centimeters, it would be centimeters squared. Or you could say square centimeters. So that's how the units of area come about. They're usually because of a multiplication. That's why the units are squared. The next formula we're looking at here is for a square. All the sides on a square are the same length. Our textbook that we use uses S, so it's not a 5, but it uses S to represent the length of one side. For a square, well, if this is a side, this is a side, this is a side, this side, they're all the same, so they're all actually called S. So the perimeter here is equal to S plus S plus S plus S, which would be 4S. So the perimeter of a square, you're just adding up all four sides. They all have length S, it's 4S. The area of a square, it's a special case of the rectangle. Side times side would be side to the second power, so side squares. You just take one side squared, that's the area of a square. Let's talk about a triangle here. All right, for a triangle, all right, we got a triangle here. I'm going to call this side A, this side B, and this side C. And I'm going to say that there's this distance from the bottom here to the top, which we'll call H for height. That means at a right angle here. So that is a distance that I wrote there in red, not part of the actual triangle. B I labeled intentionally this bottom side because it's the base, and this is the height. A and C, you know, are just variables I'm using to hold on to it. The perimeter for a triangle, we just add up the sides. It's really just going to be A plus B plus C. There's nothing special about that formula. Perimeter, you're adding up the distance around the outside. The area for a triangle, you may have seen this before, is 1/2 the base times the height. So it's 1/2 B times H. Or another way of writing that same thing, you might have heard it as area is equal to the base times the height divided by 2. Those mean the exact same thing. Right, so these are all formulas you should know. You should memorize them. We don't give them to you typically on a test. So you should know what they are. You know, the last one we'll look at here is for a circle. On a circle, you know, it's round, and it has the distance from the center to the outside has a special name. We call that the radius, which I'll label with R. And, you know, perimeter has a special name for a circle. It's called the circumference. So if you hear circumference, that really means the distance around the outside of the circle. So circumference is equal to, there's two ways you may have seen this in the past. One way to find it is to take 2 pi r, so 2 pi times the radius. Another way you may have seen this is, you know, this is the radius. The whole distance across a circle you may have heard of before. It's called the diameter. Well, the diameter is really equal to 2 times the radius, right? Going from one side to the other, there's 2 of those. So diameter is equal to 2r, so you could take this 2r here and really write this as pi times diameter. It's really your preference. A lot of the times we'll be given the radius, so it's easier to use the first formula, and that's more often how we'll write it in our class. But so circumference is equal to 2 pi r. The area of a circle, well, that's pi times the radius squared. Again, remember the units of area are going to be squared. So having that radius squared there is where the units would come from. So area is equal to pi times the radius squared. Now, if I ask you for the exact answer in a problem, the exact answer is the one where you keep pi in there. If I ask you for an approximation, that would be where you would replace pi with the pi button on your calculator to get a decimal approximation. We'll see this in one of our examples in a minute. All right, so you should know all of those formulas. Let's take a look at just two examples here. So the man wants to fence in a portion of a rectangular garden that has 60 feet long and 15 feet wide. Find the amount of fence he will need in the area of the garden. So first off, they tell us it's a rectangular garden, so that's important because we know the shape of it. I'll draw it just so we have it here. So here's the rectangle. It's 60 feet long, so this side I'll say is 60 feet, and 15 feet wide, so I'll mark this side as 15 feet. All right, and we're going to use the perimeter, which is equal to our formula from earlier, which was 2L plus 2W. So we have perimeter is equal to 2L plus 2W. We know we want to use our perimeter in case you're not sure, because where's the fence go? The fence, right, is on the perimeter. So that's how you know you're using the perimeter formula here. You also, we know the amount of fence we need. We also are going to need the area in a minute, but let's do the perimeter first. So perimeter is equal to 2L plus 2W. So substituting into this formula now, perimeter is equal to 2 times L. L is the length, which is 60, plus 2 times W, so 2 times 15. And then we're going to evaluate this, follow your order of operations. So we're doing the multiplications first. 2 times 60 is 120, plus 2 times 15, which is 30. And then, so the perimeter is equal to 120 plus 30, which is 150. And make sure you know the units on this. The units are just feet. Do not square them, right? Perimeter is linear units. You're adding up the units on the outside. So feet plus feet is still feet. All right, so the units, when I say linear units, there's no power on here other than 1, so you don't see it. So it's 150 feet. That's what? That's the perimeter, which also means it's the amount of fence, right? Make sure we're answering the question. What's the area of the garden? Well, the area, that's equal to length times width. And that means that the area is equal to, in our case here, 60 times 15. And if you multiply that out, 60 times 15 on your calculator, you get 900. And then what are the units for area? Well, the units, remember I said, are always squared, right? The units of 60 times the units of 15. It's feet times feet would give us feet squared, right? Or if you like writing it as saying square feet, that means the same thing. Or you could say 900 square feet. Those mean the same thing. But make sure that you do have the correct units. They are worth points, so you got to make sure you have the correct units on these problems. The last example we'll do for this part, we'll look at this pizza. It says a pizza has a radius of 6 inches. Determine the circumference and the area of the pizza. So first off, when I say has a radius of 6 inches, when you see that radius, you know the shape of the pizza is a circle. So here's our pizza. It's a circular pizza. Has a radius of 6 inches, so the distance from the center to the outside is 6 inches. That's what we're really doing here. Sometimes it's helpful to draw the diagram like I have here. You don't have to, but it might make it easier to see what's going on. And then we're going to use some of our formulas. We're looking for the circumference. The circumference had the formula circumference equals 2 pi r. And if you have that formula there, we already have r in the problem, that's great. If you use circumference as pi times diameter, you might have to manipulate something in here to make sure you have the correct answer. So circumference equal to 2 pi r, and then all I'm doing is substituting in for r. So we know r is the radius, pi is still pi, so we have 2 pi times 6, which is the radius. So 2 pi times 6, so 6 times 2 is 12, so this is 12 pi. Now, what are the units on this? Well, the units are right? Circumference is the distance around the outside. Those are linear units, just like perimeter is. So it's in inches. This is the exact answer. Make sure you understand that. The exact answer is the one that keeps pi in there, because pi, remember, is an irrational number. It goes on forever with a repeating decimal at the end, or with a, I should say, non-repeating decimal at the end, which means that it's irrational and that we can't evaluate it exactly. So the exact answer is actually what we leave in terms of pi. So if I don't tell you to approximate, leave your answer in exact form. 12 pi inches, that's correct. Now maybe you want something a little more practical to work with so you understand it. You could use the pi button on your calculator. Sometimes people have used 3.14. I would recommend using the pi button because it's a little more accurate. And that's what you really should use for our course. But if I was looking at this on the calculator here, if I took 12 times second, the pi button, or actually it's not a second key, so times just pi, hit enter, and I get 37.69999. Let's say we'll round to the nearest tenth just for our approximation. So that means 37.6, the 9 rounds that 6 up to a 7. So it'll be 37.7. The units are still inches, but make sure you know this is an approximation. That's why I use that squiggly equal sign, because this is an approximation now. As soon as you turn pi into a decimal, you're approximating it. Alright, so make sure you know the difference between an exact answer, which leaves it in terms of pi, and an approximation, which leaves it as a decimal. So that's circumference. For area, the area of a circle, which is one of the formulas that people tend to remember but kind of forget which one it is. The area is equal to pi r squared. The way you can remember is that the r is getting squared here. Remember, units of area are squared. So we have pi r squared. We're going to substitute in. We have pi times the radius, which we know is 6, so we have 6 squared. So 6 squared is 36, so this ends up being just 36 pi. That's an exact answer. 36 pi, what are the units? Well, it's area, the units are squared. So 36 pi inches squared, or 36 pi square inches. But this is exact, remember. This is the exact value because we leave it in terms of pi. If you wanted to approximate this, again, you could just type in on your calculator 36 times pi, which if you hit enter on that gives us 113 point, we have 0.97. We'll round the nearest tenth here, which would be 113 point, that 9 rounds that 0 up to a 1, so it's 113.1. And again, this is inches squared. This is an approximation, that's why I use that squiggly looking equal sign. This is the approximate answer. The one with pi in it is the exact answer. So if I don't ask you to approximate it, and I don't tell you any decimal places to round to, give me the exact answer. If I ask you for an approximation, make sure you do give me an approximation. You know, we use nearest tenth here because I just kind of chose that as I was going along. Typically we'll tell you what to round to in a problem if we want you to round though. So hopefully this helped you in using the geometric formulas and also learn the formula for simple interest and distance formula. These are formulas that you should memorize for the course. You know, a lot of them will be given to you in this section, but as we go further into our class, you're going to have to memorize these formulas and use them in applications.